I don't understand any of this. Oh, I need help.
I can help, and I have some friends who can help too.
No way.
Yes way. Come with me.
Alright, a period in the periodic table is one of the horizontal rows, all of whose elements have the same number of electron shells. A group is a column of elements that share similar chemical properties. With atomic number, or atomic mass, the atomic number represents the unique number of protons per specific element. Mass is the weight of protons and neutrons in AMU, which is atomic mass unit. Electron configuration. It is the distribution of electrons amongst outer electron shells, in which the number of electrons in the outer shell is constantly increasing and decreasing. Valence electrons are the electrons located in the outermost shell of the atom. Ionic charges is the charge of an atom, the charge of an atom based on the number of electrons, being higher or lower than the number of protons. Electronegativity. It is how able an atom is to take an electron from another atom, which is generally smaller atoms that take electrons from bigger atoms. Atomic radius is the term describing the size of an atom based on half the distance from one nucleus to another nucleus. The ionic radius is when gaining and losing electrons, the atomic radius will increase or decrease. Ionization energy is the energy required to remove the most loosely bound valence electron from an atom, which is the opposite of electronegativity. Chemical reactivity is the tendency of a substance to undergo chemical systems.
This is the table we all know. It shows many helpful periodic trends that explain why it's set up the way it is. The vertical columns are known as groups. These groups show similar chemical properties that help identify an atom the way it is. Next, we have horizontal rows, which all share the same amount of electron shells. These shells, for example, calcium and potassium, all share the same amount of electron shells. As we move left to right, you'll notice that the atomic number and the atomic mass increases. Atomic number is the number of protons, which is specific to each element, and the atomic mass is the number of protons plus the number of neutrons, which is also specific to each element. The next periodic trend is known as atomic radius. Atomic radius is essentially the size of an atom based on the center of the nucleus to another nucleus divided by 2. Larger atoms happen to be on the left side of the table, and smaller atoms are on the right. This then relates to two other trends, known as ionization energy and electronegativity. Electronegativity is the ability to gain an electron based on the size of the atom. For example, oxygen would have a better electronegativity than beryllium.
As for ionization, it is the energy it takes for an atom to lose an electron.
So, arsenic is more likely to lose an electron than sodium. Finally, we have some flaws in the table. For example, there's no way to determine an ionic charge based on this table because all of the elements in this table are stable and have neutral charges. Also, when it comes to electron configuration, it's a pretty easy pattern starting from hydrogen up until we get to argon. Then, once you get to the D block, it becomes a bit more complicated, which is why this table is not good for electron configuration. Then we do have some exceptions to atomic mass. Even though generally it goes in increasing order, there are some atoms that are an exception to that. Another periodic trend is known as chemical reactivity, is shown on this table as you go towards the center. The center of the table is much less chemically reactive than the outsides, except for when you get to the noble gases, which is the far right column. The noble gases have no chemical reactivity. The chemical reactivity of the left elements, the alkaline earth metals and alkaline metals, increases as you go down the column, and on this side, it decreases as you go down. Another exception to the periodic table is that with ionization and electronegativity, noble gases don't have either. Another exception to this periodic table is that hydrogen is not a part of its group because it's a non-metal that acts as a metal.
Got it.
Hi, I'm Riley Loftus, and I'll be talking about the spiral periodic table, which was developed by Theodore Bedford in 1964. It starts with hydrogen in the center and spirals out in order of atomic number and atomic mass, with a few exceptions also found from the modern periodic table. It is color-coded based on groups, but there is no key to go with the colors. Each spiral is a period. And you can see the F and the D block, but you cannot see the S or the P block. The farther from the center of the spiral you get, the more the atomic radius and the ionic radius will increase, and the more the electronegativity and the ionization energy will decrease. Got it, Joe?
Yeah, I think so.
Hello, my name is Jaish and I'm going to be teaching about the physicist periodic table. As you can see, instead of the normal periodic table, the elements are assigned by how they're organized in their sublevel. And the white one will be your S sublevel, the orange will be your P sublevel, the salmon color will be your D sublevel, and then your blue will be your F sublevel. And then so usually atomic number, atomic mass, or what type of family they are can usually be seen by the box. So if you modified this, you can see that more clearly. But one thing you can do to see a family is excluding hydrogen out of the alkali metals. All of these are alkali metals, and all of the Be and the things that are going down of Be would be your alkaline earth metals. And then how you can figure out periods like correlating to the normal periodic table. For your D sublevel, you would add 1 to make it sure that would be in the 4th period. For your P sublevels, you add 2 to which sublevel, which orbital it is in to get your period. Some periodic trends you can see in it is that when you go down, your atomic radius increases because you have more levels, which means you have a bigger radius. But when you go but if it's on the same level, things that will have a greater atomic radius are the ones that have a lower atomic number, because once you have more protons, that usually correlates to a decrease in the atomic radius, and that's the same with ionic radius. Except with ionic radius, there's a trend. For metals, if the higher atomic number will have a larger ionic radius. But if it's on total, you get to the non-metals. So the non-metals, there's going to be a spike in how much in the ionic radius. So between lithium and B, that's your kind of separation between metals and non-metals. And over here it will be this little dot. Over here it will be there. Over here it will be here. And over here it will be there to tell you the difference between your metals and non-metals, because you have to remember that the ionic radius has a big increase and then starts decreasing again. And the electronegativity, it decreases when you go down, and that's the same with your ionization energy. When your atom is an ion, the ionization energy decreases when you go down. And that's things you have to know about the physicist periodic table.
Oh, I think I get it now. So, in the physicist table, it groups everything by sublevels. And you can clearly see the different groupings of the elements because they're color-coded. So everything is pretty well displayed, but it's kind of hard to see the individual electronegativity in periods that are the same. In the spiral table, you can see it has a lot of the same traits as the modern periodic table, where it spirals out and increasing in atomic number and mass, except for a few exceptions. But it's hard to do electron configuration because you really can't tell the different groups from each other. It also shows some periodic trends like atomic radius and electronegativity, because atomic radius increases as you go outside the sphere and electronegativity decreases. So the atomic radius increases as you go down, but the electronegativity and the ionization energy decreases. And then going left to right, your electronegativity increases while your atomic radius decreases. Also, you have to keep in mind that the ionization energy for nonmetals is greater than the ionization energy for metals. Also, ionization energy follows the same trend as electronegativity. It decreases as you go left to right. It's also easier to see the chemical reactivity in this table. You know that it's more reactive on the sides, discluding the noble gases, and less reactive in the middle. So everything in this table you can see much more clearly than every other table, and it's more summative than everything else. Honestly though, I think I prefer the modern periodic table. It lets you see the trends much more easily. You can clearly see the D, P, S, and F groups, as well as different periodic trends. I just don't know what this is good for. What is the purpose of this table? This is completely useless.
Energy loves you.
Who would use this? I think this is the most useless table I've ever seen. But
I like it.
So let me tell you.
Something that Morgan succeeded in doing was like,
I don't need to burp.
I'm speaking, Riley.
oh my gosh,
No,
guys!
let me continue. This is important. Hey, what's up, Joe?
Yeah!
He was going like,
Pole.
I'm bad at using the stick.
Points D.
I'll do it.
Points of a D block. Yeah, Lemmer, I'm gonna do it.
I'll do it. Just like. Okay. You got this.
Okay.
Action.
just don't understand any of this.
And I have some friends who can help too.
No way.
I can help, and I have some friends who can.
I'm not.
And that color is gonna be your
Salmon.
Peach.
Peach salmon. Like pink.
You stop the video for 1 second.
Got it, Joe?